Hi all, this is Alan with Bothell STEM Coach, and today we are going to do some more AP Physics 1 circuit problems. As usual, I suggest you pause the video and try to do the problem yourself, and then come back after you've attempted the problem. So we have a certain light bulb is designed to dissipate 6 watts when it's connected to a 12 volt source. Calculate the resistance of the light bulb. Well, we know that the power is equal to I times V for a resistor. It's also equal to V squared over R, or I squared R. Now, I know it's a 12 volt and 6 watt rating, so I know power and voltage. So R, I'm going to use the P is equal to V squared over R. So R is equal to V squared over P. That's equal to 12 volt squared divided by the power, which is 6 watts. What's that? 144 divided by 6, that's what, 24? 24 ohms. That's the resistance. B. If the light bulb functions as designed and is continuously lit for 30 days, how much energy is used? Well, the change in energy is always equal to power times time. So we're consuming 6 watts the whole time, and then it's 30 days. Time has to be in seconds. So yeah, I mean that at least in terms of if you want your units in joules, you would want this in seconds. So this is gonna be 30 days times, let's see, in 24 hours, 1 day, times 60 minutes, 1 hour, times 60 seconds in 1 minute, right? So the days cancel, the hours cancel, and the minutes cancel. So it'd be watts times seconds, which is fine. That's 60 times 30 times 24 times 60 times 60. So I got 1,555,2000 joules. And if you wanted to do this in, let's see, yeah, that would equal 15.552 megajoules of energy. Okay? Which sounds like a lot, but it is, but not as much as you might think. On the diagram below, draw in wires connecting. Oh, actually, no. So it's a 6 watt 12 volt bulb connected circuit with a 1500 watt 120 volt toaster, an adjustable resistor, and 120 volt power supply. The circuit is designed such that the bulb and the toaster operate in the given values, and if the light bulb fails, the toaster will still function at these values. On the diagram below, draw on the wires components to make the complete circuit that will function described above. Well, if this is the key part that's saying it's like if the light bulb fails, the toaster will still function. So what you need to do is you want to put them in parallel. So I want this thing. Let's see, draw wires connecting. So I want the 120 volt to definitely go into the toaster. Okay. Because I want this to work regardless. So I want it parallel with all of this. The second thing is to say, well, I can't hook 120 volts directly to the 12 volt bulb. So I'm going to put in this resistor here. And that will allow me to control this voltage drop so that I have exactly 12 volt drop like that. So that would be good. So that would work. Determine the value of the adjustable reacher that must be used in order for the circuit to work as designed. Okay, so I'm going to simplify this circuit. I have this 120 volt. I have an adjustable resistor I'm putting here, which I'm just going to call R. I don't know what R is, but I'm going to set the R value. And then I have my light bulb, which we model as a resistor. It's a 24 ohm resistor. Okay. Now the key part of this is that this needs to be 12 volts over here, and this is 120 volts. Okay. Also, how much current do I need through here? Well, this current is supposed to be, I can look at this equation, because I know it's 12 volts across this resistor. 12 volts over 24 ohms, V over R is going to be, this is 0.5 amps. So I know I need a current of 0.5 amps to go through here, but that also means I need 0.5 amps to go through here. Okay. So this, again, is V equals IR. This is the relationship. Now, let's look at the voltage across this resistor. The voltage is 120 minus 12 volts, because we're looking at the difference between the voltage. Like, this is 120 volts relative to here. This is 12 volts relative to here. So relative to each other, it's 108 volts is equal to I, which is 0.5 amps, times R. So I can solve for R by doing 108 volts divided by 0.5 amps. That would be, what, 216 ohms. So that's what I would need the adjustable resistor to be at, 260 ohms, so that when I'm using my 6 watts of power, I have exactly 12 volts here. If the resistance of the adjustable resistor is increased, what will happen to the following? The brightness of the bulb. Well, if I increase this resistance, then the total resistance is going to increase, and thus the total current is going to decrease. So for one, I would say total R increases. That means I decreases, and that means power decreases. So that means it will be dimmer, because the brightness of the bulb depends on how much power you cram into it. The more power you put into the bulb, the brighter it will be. How about the power dissipated by the toaster? The toaster won't change, because the toaster has the already, it will still have 120 volts across it. So this, because basically if I reduce the current here, not necessarily going to increase the current here, because it kind of just depends on what the toaster is doing separately. So yeah. Okay, I hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content, and see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.